If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all once again to lecture 4 of this engineering math differential equation series. So today again I have taken 3 questions, question number 10, 11 and 12. Some differential equations, 2 variable, multivariables are there. So okay, then let's start. Let's start from question number 10. What is asked? This is the differential in 10. This is the differential equation they have given, and they have given x10 is less than equal to x20, which is less than equal to alpha. Then they have given some final value. Which of the final value will be smaller, less than or greater? They are asking x1 final and x2 final. So you have to limit x tends to infinity at you have to find this final value, and you have to compare this final value whether they are equal or less than or small. Now again you can see the initial values are directly not given, so it's better you will not go by Laplace. So you will go by normal way. So normal way, if we put instead of d we will put d. So how we solve one? It will be capital D x1 then x1. So if you take x1 common, it will be d plus 1 x1 minus x2 is equal to 0. This is my first equation from this, and if you take this one again, if you put this d, so it will be dx to this side, so d plus 1 x2 and then minus x1, this is equal to again 0. So if you solve this one, that is, this is equation 1 multiplied with d plus 1 and then you subtract it with 2, then what it will be? Okay, let me do it. D plus 1 whole square x1 minus d plus 1 x2 is equal to 0. So finally if you deduct these two, if you add these two, finally if you add these two, you will get this one. So if you write the auxiliary equation for this first x1, so it will be m square plus 2 or m equal to 0 or minus 2. So from here only you can find x1 will be equal to c1 e to the power 0 t plus c2 e to the power minus 2t. So it is c1 plus c2 e to the power minus 2t. Now you need to put this value of d1 in any one of the equation, either in equation 1 or equation 2. So if I want to put it in equation, because I need to find x2, so it's better if I put in equation 1. Why? Because if I put it in equation 1, then x2 I can directly get. But for that I need not only d1, I need d plus 1 x1. So for that I need to d of x1. What is d means? One time differentiation. So it will be minus 2 e to the power minus 2t. So if you add these two, then you will get d plus 1 x1. Why I am doing? Because I need d plus 1 x1 in equation 1. That's why. So c1, if you add these two, c2 and minus 2 is equal to minus c2 to the power minus 2t. So you need to put this value in equation 1. So from 1 you will get, if you put this value there, you will get x2 is equal to d plus 1 x1, d plus 1 x1. So what is d plus 1 x1? c1 minus c2 to the power minus 2t. So now you have x1 also. This is your x1, this is your x1, and this is your x2. So now you can calculate at t tends to infinity. If t tends to infinity, what will be your x1t? If you put in x1t infinity, then e to the power minus infinity is 0. So it will be 0. So it will be c1 only. And what will be x2t? If you put again infinity there, if you put infinity there, then it will again 0. So it will be again c1. So both of them are equal and then finite. So what will be the option? That is option C. Both of them are equal. x1 final is equal to x2 final, and both of them are less than infinity. Infinity means it is some finite value. c1 is some finite constant. Okay, so you can see when to use Laplace. Laplace we will be using if the initial conditions are properly mentioned, then we can use Laplace, then it becomes easy for us. But if there is a problem in initial condition, then it's better to go to the, okay, so in 11 it is given t square minus 81. So in equation question number 11 it is given t square minus 1 dy dt plus 5ty is equal to sin t, where y1 is some initial condition is given. There exists a unique solution of the differential equation if t belongs to the interval. Now they are asking to find that. First let me put it in a good shape, because we don't want to put t square along with multiplied with this one. So what you will do, dy dt, if you divide it this one, t square minus 81, then how it will look like? It will look like a linear differential equation. In the last class we have, or last to last class we have seen linear differential equation, dy dx plus py is equal to q. This was the format for linear device. So there you can see it is p, it is q, where we have used integrating factor if like that. But here they have not asked you they have asked you which of or what value of t in the interval the solution, there is a unique solution of this one. Now you can see if t square minus 81 in the denominator, then what it cannot be equal to 0. If it is equal to 0, that means t cannot be equal to plus 9 or minus 9. If this is equal to 0, then this defined differential equation becomes undefined and we cannot solve it. So you see the options now. Here it is minus 2 to 2. Okay, let it be there. I am eliminating some option. I am seeing whether the options containing 9 or minus 9. If it contains minus 9 or plus 9, then obviously that will not be the answer, because in this case it cannot be plus minus 9. So obviously here you can say 9 is also there, minus 9 is also there, because minus to 10 you are getting. So you will also find in between, somewhere you will find minus 9, somewhere you will find plus 9. So this will not be the answer. 10 again minus 2 to 2. So here you will find minus 9. Because if you come from minus 10, then next it will be minus 9, so it will not be the answer. And then 0 to 10. So here 9 is included, so it will not be the answer. Because these two cannot be included. Because if it is included, then this differential equation becomes undefined and we cannot solve it. So that's why the answer lies here in option A. Nothing to solve here, just to check. Yeah. So if you see the question, don't start solving the question. You see, understand it, and you see the options. Because we have options, those questions where you will have options, that will give you extra benefit. You check with the options whether you can eliminate some option and you can come up with a nice answer without solving it. So in 12 it is a differential equation given where all these initial conditions are given, y0 0 and y dash 0 is equal to 1. So it is good, we can use Laplace. So if you apply Laplace here, so you can write s square minus s x0, the s into x0 0 minus, still I am writing, but I think by now you have already understood this is x, or this is not x, capital Y, sorry. So dy dx, so here it is y. So sy minus again 0, this is the initial condition that I am putting 0, plus 4 into y, it is 0. So by seeing the differential also equation also you can write Laplace if you practice a little bit, but I am showing you in details here. S will be 0, so it will be plus 1 only. So y will be equal to 1 by s, I think it is minus 4s. This is minus 4s. So it is minus 4s. So it is s minus 2 whole square. Now 1 by s minus 2 whole square. Now what is the Laplace inverse of this one? You should know this one. What is the Laplace inverse of s minus 2 e to the power 2t? Let me write it in this way. This is normal of 1 by s minus 2. But you are differentiating. You see, if you differentiate dds of s minus 2, what it will be? Minus 1 by s minus 2 whole square. So because you are differentiating it, that means there should be something. So it is t into this. That means I am talking about this formula. Laplace of t to the power n ft is equal to minus 1 to the power n dn dx to the power n of f dash. If time domain you multiply in t, in s domain you differentiate it one time. So for one time multiplication, actually the one time one you can remember, that is mostly used. So it is minus dds of fs. So whatever the normal fs you get, normal fs of e to the power 2t is 1 by s minus 2. So if you differentiate it, then you will get this one. So it is t into function. So you can see here. So this is very important. You no need to read the formula. You just need to know the property. In time domain you multiply t. In s domain this is differentiation. So t into ft. So t into e to the power 2t ud. What you will do? You will do minus dds of, what is e to the power 2t? 1 by s minus 2. So this minus and this minus get cancelled. So that's why no minus is there. So if you take inverse, so it will coming this much. So I think they have asked you to find y1. y1 means when t equal to 1, what is the value of y? So if you put t equal to 1, 1 into e to the power 2. So e to the power 2, if you put it is 7.38. E value you will get 2.71, around this. So you will get it. If you like the video, then press the like button and please give your valuable comments in the comment section.